Hey everybody, this is Mike. Welcome back to the Z Motorsports shop and channel. Today's project is we're going to be fabricating a small cart for my DI system, for my deionized filtration system. I've been researching these various systems out there for a few years now. I haven't been able to make up my mind. Last year getting our coach painted and got me thinking more and more about it this year. So between trying to keep my wife's car, my Jeep, my truck, especially the motorhome washed, there's a lot of time involved with that. And I'm trying to cut that time down, number one, and number two, less I actually have to put my hands on the paint. So in the past, washing the motorhome has been running around it from the top down with a boar's head brush, and then doing the bottom with a lamb's wool mitt, rinsing it off, and then going around it again with a chamois and drying it up on a 10-foot ladder and moving it in, I don't know, 3-4 foot sections. Takes me about 2 to 2.5 hours a time to wash it. Now granted, at our last place where the motorhome sat outside all the time, basically I was washing it twice as often, because we'd wash it when we got back from a trip, and then I'd wash it usually the night before we left to get ready to go on a trip. So now we're able to park it inside. We wash it when we get back from a trip and back it in its garage, and it stays nice and clean and is ready to go until we're literally pulling out of the driveway to go on a trip. So I automatically cut my washing time in half just by doing that. But it's still 2.5-ish hours to wash that sucker. So if I can cut that down to even cut that into half, even that down to 45 minutes to an hour to run around it with a hose. And I bought one of those, what they call them, soap bombs that you use, hook up to a hose, put your washing solution, I guess, shampoo, shampoo, auto shampoo in the bottle, spray it on, and then go over it with a boar's head brush and a lamb's wool mitt, and then run it through a DI system, deionized filtration system, and rinse that water off and basically walk away and not have to touch it. I'm hoping I can get that down under an hour and end up with as good, if not better, of a shine by the time it's all said and done. So that's my purpose here. And then also our regular daily driver vehicles. My wife's car, I'd like to be able to keep it washed at least once a week or so, and it'd be nice to be able to have her get home from work, pull it around back to the shop, let me run around it real quick, and park it in the garage and not have to chamois it. Maybe run a vacuum through it and wash it in a matter of 20 minutes or so. I've been kicking it around, and I stumbled across this DI rinse system, and this is the one I ultimately ended up going with. You can supposedly put at about 110, when it starts out at around 110 parts per million on your water, going through it. They're claiming it'll last around 4,000 gallons. So that's a lot more washes per resin cycle than anything else I looked at. So that's the one I ended up going with. I ended up going with the Pro100. It's the larger system of theirs. I'll go ahead and put a link in the description of the one that I ended up going with, but they also make a Pro 50, I believe it is. It's a smaller one, so if you're looking for a more portable or something you can put in the storage bay of your RV, that's one way of going. Again, I went with the larger system. It's probably a 36-inch tall tank, fiberglass tank. Looks like a very well constructed tank. It has the resin. It's what they call an updraft filtration system, meaning the water goes down around the resin, and the filtered, clean, deionized water comes up the tube and out the outlet of the tank. Another thing I liked about this one is when the valves are installed on it, you actually have a bypass. So when say you're hosing the coach down, hosing the vehicle down, whatever, you put this in bypass because you really don't want to be using deionized water for the preliminary washing stages. Your deionized waters you really just want to use on the final rinse. So you can go ahead and shut these valves, turn it to bypass so that it turns the water off going in and out of the tank and just goes straight past it for your preliminary washing and soaping it up and everything. And then when you get ready to do the final rinse, you turn the valves so that they go through the tank, and you're getting deionized water for their final rinse. So that was another thing I liked about this one. Otherwise, I mean, it's not the end of the world. You can do the same thing on the other one. It's just you have to go through and put together the plumbing system on it. Again, not the end of the world, but this one already comes with that feature, which is kind of nice. It has a meter to measure your parts per million. It comes with the other fittings that go off your manifold there for the hose connections, funnel for your resin. And then I went over just my local Tractor Supply and picked up a couple of 8-inch rubber wheels with a 1/2-inch bore and bearings in it. I'm going to go ahead, and today's project basically is going to consist of building a cart for my tank. I want to be able to have it portable so I can put it in the RV storage bay there when I'm not using it. When I get ready to wash, I can just open the door, roll it right out along with my washing supplies, and it's right there ready to go, and I can roll it around as needed. And I'm assuming once it gets full of water, and it's not light by any means already, but once it gets full of water, it's going to be even heavier. So I decided to build a little cart. So that's what today's project is going to consist of. The tank measures about 9 inches in total diameter. I think I've got some 1 1/4 DOM tubing left over from my sandrail when I built that. So I'm going to go ahead and build a hoop and for the bottom for the tank to sit on. And then I haven't decided whether I'm going to build a hoop that comes up and over for the backrest of the tank, or if I'm just going to come up with a single with the handle and then a couple of pieces of tubing bent where the tank will sit inside of there and strap it into the cart. So this is kind of, I don't really have any drawings or anything hard plans. This is kind of going to be a wing it as we go plan. So I think first of all I'm going to go ahead and we'll go over here to the tube bender, and I'm going to bend up a hoop and get it all fish mouthed and ready to go and basically build the base. And then we'll just work our way up from there, the base, and then I'm going to put, it'll end up being about 4 inches off the ground because these are 8-inch diameter wheel. So the base will be pretty much, give or take, probably 3/4 of an inch or so for the axle center line. The wheels will be approximately like so. The hoop will come out, have an axle across it. Haven't decided what I'm going to do yet for the legs for the cart. And then from there we'll build either the hoop or the single. Like I said, haven't quite gotten that far yet in the design. It's still kind of coming together up here. So let's go ahead and build the bottom piece and kick this project off. All right, so the tank, like I mentioned before, the tank measures 9 inches in diameter. I'm using my 1 1/4 die. It has a 4 1/2-inch bend radius. So that should get me pretty close to that 9 inches for the base for the tank to sit on. And then I may have to put some tabs underneath. Kind of depends on how it comes out, but at least I'll put some tabs, maybe 3 or 4 tabs coming up from the sides just to locate that tank on the hoop once it's sitting on it. But for starting, I come in about 8 inches. I'm going to have to trim this to length, but I come in about 8 inches to where I want to start the actual 180-degree band. So I've put a reference mark, lined it up with my die. Gone ahead and got the tube, the 1 1/4 tube in the die. A couple other things I may or may not need, but it's easier to do at this point in time. I've got an adapter here that I made. It's just, I can clamp it on. I've got 2 90-degree surfaces here for putting a level on. So I will go ahead and secure that to the tube, make sure it's level. And if I ever have to pull it out of the die, or if you're doing multiple angles, it's generally easier to just go ahead and level it up. Then you can leave that on while you're pulling the tube in and out, doing whatever it is you need to do. But yeah, that remains your reference point. Like I said, on a simple 180 band, I doubt I will need it, but if I do, I've at least got it there. So I've just kind of gotten in the habit of always putting that in place, and if I don't need it, no big deal, no harm, no foul. But if you do need it and you haven't put it on, it's harder. You got to take it over to the bench, you got to lay it down flat, get everything referenced, and then put it on. It's just a lot easier to just get in the habit of doing it each time. And then I've got a magnet that I converted over to a pointer, so I just go ahead and run it down on, put it and zero it out, and I'll run it to where I just take out the slack of the system, which is right there. And you can tell when the following shoe and the die come into play, you can tell right when it zeroes that out. So went ahead and took the slop out of it, just put a little snug up there on the tube. And then the other thing I like to do is I'll just take a little bit of some kind of lubricant. I just usually use WD-40, and I'll shoot it around my following shoe and just a little bit into my die, just to act as a little bit of a lubricant as it's drawn that tube through the die. So now I'll go ahead and hit it, and I'll run this over to 180. Now, I've got the hydraulic attachment on my tube bender, but I still have to, I took the ratcheting mechanism off, but you'll notice I'll still have to keep coming back and advancing the holes in the die to make that full band. Okay, when you get to the end of the one stroke, go ahead and release it. And this is where you want to make sure you have this snugged up a little bit, because if not, it'll relax everything and your tube can twist a little bit in the die. So once it's gone ahead and relaxed, I'll go ahead and pull it to the next, retract it until it goes to the next hole and advance it again. Now, one thing I want to mention also, you notice I backed that off. I had gone to about 184 degrees and backed it off, and my needle now is right at 180. So every tube composition, so material, diameter, they all have a different what they call spring back. The good thing, the important thing I should say, is to know the material you're working with, especially if you're doing a lot of repeatable bends or a lot of bends in general, where you're going to be using the same tubing. I like to do, if I'm not familiar with one, I'll do a test bend on one and see what kind of spring back it has. I remembered from when I built my sand rail on this one that I usually had about a 4.5 degree spring back on this diameter tubing, and sure enough, memory popped back, and I'm just a pointer's width, so maybe a 32nd of an inch past the 180. But that's pretty accurate. The important thing is, like I said, you want to make sure you know the material you're bending. When I was building my sand rail and a lot of the ATV chassis, when I was building them, between DOM tubing, chrome moly, everything has a different spring back rate. So if I'd get a new batch in, I'd do a test on different sizes and make a note of it, so that I could repeat those bends and not have to inch up. I could, if I wanted to bend 90 degrees, I'd go to 92 and know when I released that tube, I was at 90 degrees. You can pull up to 90, go to 91, then back off. Go to 92, back off. But there's a lot of time wasted there, so it's just better to know what it is you're bending and have that data either written down or in your head or something, so it helps you be more proficient at what you're doing. Spot on. Center line of the tube, 9 inches. 4.5 inch bend radius, that should be 9 inch. So I'm gonna go ahead and pull this out and cut it off, and then we'll go over and kind of fit it to the tank and see where I want a fish mouth and run my piece across, and that'll basically complete the bottom piece, and then I'll determine where I want to put my axle, how I want to mount my axle. Do I want to mount a solid axle? Do I want to just use a couple of studs coming off? I honestly don't know yet till I kind of see what I'm doing. So I'll go ahead and pull my pointer off. I can go ahead and pull my reference point off and pull the tube out of the die. All right, so I just went ahead and did a test fit, and there again, 9 inch bend radius, center of tube to center of tube, 9 inches right in the money. The tank sits on it, and it follows the center of the tube all the way around. So perfect, that's just what I was after. Now, while I've got it here, the tank sitting on this, you maybe saw the light bulb come on. Actually, I think what I'm gonna do is I'm going to fish mouth this tube and put a piece right across the back side here, where the axle will more than likely, what I'm going to do is fish mouth a tube, run it across there, and then I'm actually going to make a reducer in that tube to run the axle shaft through, and probably just come in from the other side, weld the axle tube. Well, maybe a solid axle running through. I don't know. I haven't decided that. I haven't got that far ahead yet. But then the wheels will sit off the side here. So the 4-inch axle center line will be right here, dead center of this rather than underneath. So that'll bring it, you know, roughly 3/4 of an inch to an inch lower to the ground. I don't want to have this thing up too high. But then my real light bulb just come on is, as this tank is sitting back in here on this, I notice that if I come up from about right here, where the apex of the tank mates, the outer circumference of the tank meets the tube, if I put another tube, I've got plenty of this 1 1/4 left over, this DOM left over. At first I thought it might be a little heavy for this project, but I've got plenty of it left over, and it's only 0.95 wall thickness. So I think what I'll do is I'll come up, bend a radius that goes right around the top of this tank, so that the tank kind of will fit into where that hoop goes around. So and then come down to the other side. So basically, instead of having to put another hoop or something for the tank to sit into, the tank will actually sit back into the hoop, and then I can put a couple of attachment points midway, or probably 2/3 the way up, with like a tie-down strap around it to hold it into that hoop, and that hoop will basically just kind of cradle the tank as it sits back into it. And then out front here, I'll probably put like a tab on either side, and maybe one on the nose, for the tank to sit, the base to sit down into and orientate it. And then you'll put it down in, and then set it back into that back hoop. Then coming off the top of that back hoop, I'll put a handle. Quick and simple. So I think that's what I'm going to do. So I'll go ahead and get this base notched, and then I'll figure out where to, based on the bend radius, where I need to start the bend in order to go up and around the top of the tank. So I have one more 180 degree bend to make on this, and then the handle coming off will probably, I don't know, be somewhere around a 30 or 40, probably a 30 degree angle for the handle. Okay, sounds like a plan. Okay, so I have the upper hoop bent now, and cut the length. So we are going to go ahead and level this up so it's at a true 90 degrees and perpendicular to the one we're fitting it to. Okay, bubbles right there. So we will go ahead and commence. Now when you get to the end, you want to be especially careful because it can actually grab and break teeth off. So I'll push it a little bit till I get to the end. And then when I start getting close, I'll back off on pushing to kind of let the drill or the hole saw nibble away at it. You see how much easier it didn't catch and try to grab by just kind of a balancing act between being, you want it to be quick and push through fast, but in the same token, you don't want to chew up hole saws unnecessarily either. So now I'm just going to flip it 180. And as you get near the end, let off. You can hear the tone change as I let off and didn't push quite as hard. Okay. So now that's fish mouth. Now, let's see, hopefully that'll show up. When you get this, these are going to be razor sharp. When you go to weld those edges are going to burn back quick. So take a Rolock disc, sanding disc, whatever, and go around and knock that razor edge down so you get more of the total wall thickness out here on this coped end. So that way, I mean, you've already got wall thickness on the the deepest, the most concave part of the fish mouth. But out here on the peaks, that's razor edge. You're going to want to grind that back or sand that back. On this one, probably, I'm going to be close to a good 1/16 of an inch before I get, maybe even a little bit more, before I get full width. Now before you weld, take some acetone and clean, because you notice I did get oil when I was cutting that, so just take a little bit of acetone. And actually I always go over to the wire wheel and run around it also and get these little burrs off the inside, or you can run a burr tool around, either one. So here you can see about where that's going to sit with the 9 inches there. Back to there. Yeah, that's about 8, about 7 3/4 to the front, and the tank's going to sit back here. So that's probably pretty close to where it's going to sit. I'll go over and fit it to the tank and measure it, mark where it's going to be welded, and then we'll determine where we're going to fish mount the bottom hoop to put the axle tube across. And then I guess the next piece of the puzzle is going to be to notch this bottom, fish mount this bottom piece, and then machine the axle. So I think I'll fit this to the tank real quick. So there's the bottom piece fit, and the top piece will be brought in about right there. Tank nestles nicely in behind there. So yeah, I think that's going to work perfect. Put a little hook with a strap that goes around the tank, and that's going to nestle in there beautifully. Line up my legs, and then I know if I measure off that corner back, so that's 9 1/4 to where I'm going to fish mount this one. And I measure back on this one, and I know my measurements are going to be the same. So line this straight edge up, measure off of this surface on both of them. I know I'm going to be right on. Now another way you can actually do this as well is if you kind of have to go by feel, but if you feel where that bend starts, you can feel slight indent. Just take your thumb and run it over. You can feel where where the die actually started bending. So go ahead and put a mark. Do the same thing over here and put a mark. Then go ahead and measure off of that mark. And I'm 4 inches to my mark. And go over on this side. Let's just transfer that mark around. And I'm 4 inches on that mark. So either method works. You can measure from the start of the bend back, or like I said, I know my corners are 90 degrees, so I can line up an edge, measure off of it, and I know I'm going to be right there. So use a square even if you have to. So I'm going to go ahead and cut the excess off. So from where the bend, from where I'm going to fish mount it, I'm going to come over here and cut back about 3/4 of an inch. And go over the bandsaw and cut those off real quick. Right, go ahead and fire up the saw, cut those legs off. Okay, so this in here, you're going to want to do the same thing, but this distance being coped the opposite direction, so we're going to bring that up to level, snug it down, go ahead and brush a little cutting oil on it. Okay, that's all knocked down to full width, ready to accept an axle now. We just got to build the axle. I think I have a plan here, and so we don't have to reinvent the wheel, and I thank you for those that got that. I think what I'll do is I cut a piece of tubing. We've already fish mouthed our lower hoop. Cut a piece of tubing and put a slight chamfer on the OD on both sides, deburred the inside. That will reside right there. It sticks out about, I think I made this a 1/4 inch longer, so it should stick out 1/8 of an inch on either side. So then, I've got some 1/2 inch bolts that I'm going to use for my axles. And what I will end up doing is cutting the heads off. And I'm going to machine, this is 1.5, I believe. Yeah, it's 1.5 inch. I think this is just 1045 bar stock. So I'm going to turn it down to 1 1/4 so it matches the OD, and then step it down slightly where the axle will butt up against it. Drill a 1/2 inch hole in it, put the bolt in, weld it from the back side, and then go ahead and press this into the tube and weld around it, so I will have an axle sticking out of either side. Just quick and simple. I thought about using a piece of 01 drill rod and running through it, but to me it kind of seems like a waste of 01 drill rod because it's not really doing anything in the middle. I could thread each end and put it through, that way the axle is replaceable, but I don't think this is going to be a highly required serviceable part, so I think just welding the bolt in there is cost effective, quick, simple. So I think that's the path we are going to take. So I'm going to go over to the lathe now and machine a couple of tube adapters and then knock the heads off of the bolts, and we'll proceed from there. All right, so I have my 1.5 piece of cold rolled bar stock here in my 6-jaw. I'm going to go ahead and face it, and then I will take it down to the 1 1/4 inch OD. And I think if we go, oh heck, if we stick that piece inside of there 3/4 of an inch, that ought to be more than adequate for this, I would think. So if we do 1.5 inches, yeah, if we do 1.5 inches, we should be just fine. So go ahead and face this off. Go in here and touch off, and then we'll decide, and we'll see how much we need to take. I'm going to double check my height with my tool real quick, and then we'll touch off, take a measurement, and decide. Perfect, right on. And we'll decide how much, how many cuts we'll make to go across that. And pushing that a bit, but make this carbide work. Take another 50 thousandths cut. Pilot hole, and then we'll come back with probably 7/16, and then we'll ream it to a half so we get a nice finish. Although it's probably a little overkill for just a bolt. Drill, go ahead and slow her down just a little. Chamfered. Now let's go ahead and part it off. Which would I say 3/4 of an inch. I'm going to go 10 thousandths over to allow me to turn it around and face it. Doesn't need to be, again, this isn't a critical measurement, but I like to work to specifics. Okay, now when you're parting, make sure you slow the machine down. So I'm going to actually go into low speed here. Another thing I like to do is actually put a rod or something into it to catch the part you're parting off. That way you're not trying to catch it with your hands. Now once you get inside a little bit, you can go ahead and take a file and go in and kiss each side of that. But where I'm going to pull this out, turn it around, and put a chamfer on the other side for the weld, it's probably a little overkill. And I'm actually going to put a pretty good chamfer on this, so where I weld it into the tube, so I'll face it and then turn down the step here as soon as I get done with with parting it off. Now I think I mentioned it in my other videos as well, but I'll go ahead and touch on it here. You notice that the part dropped off. I don't know if hopefully it showed up in the video, but the part dropped off, but yet there was still a slight raised edge on the part still in the chuck. The reason for that is I cut grind rather, the front of my parting tool at a little slight angle. That way as it's going in, the part that's being parted off is going to get a nice clean edge that's going to drop off before the other side does. So let's go ahead and pull that out now. You can see the nice, well, that's going to show up or not. Yeah, you can see where the nice clean edge is cut right off of that. So I'll go ahead and turn this around, face it, and drop a step in it, and go from there. So go ahead and cut the other one and get to this point on the other one. All right, so I've got this piece chucked up there in the chuck, and I need to turn the diameter down to 1 inch 20 thousandths so it presses into that tube. And I'm going to take cleanup, which is about 10 thousandths off the face, because that's what, and again, this is probably overkill because this part is never going to be seen. But I am going to face it off nonetheless. So come in to 0.
There we go. There we go, that'll work.
Okay, there's one done.
All right, so I just got it in a collet now, and I'm just lightly putting a chamfer.
Put a chamfer on that inside edge.
And there are my 2 tube adapters. So I'll go ahead and cut the bolts off and put them in and weld them in, and then these will go into the tube when the axle's ready to be welded.
Okay, I am hell-bent determined to master this aircraft positioner. So you really have to think kind of three-dimensionally as far as both feet and hands going. So struggled the last couple times I've done it. I haven't been as consistent as I would like. So I've got my rod end, or not my rod end, my tube end. I put the chamfer on it over in the lathe. I've machined both of these. The bolt is just a 1/2 inch grade 8 bolt, and I've just knocked the coating off so that when it goes, I thought I was gonna have to cut the head off, but it's actually smaller than the end that goes in the tube, so it'll work just perfectly. And I will just go ahead and run a bead around the head of that bolt. So let's give this a try. Luckily, this is going to be inside the tube and not very noticeable. So this is as good a place as any to practice.
Get my other foot here.
And try to get my speed set where I think I'm going to be dabbing and moving. And I think I'm going to be pretty close right there. So I'll establish the puddle, and then I'll go ahead and start on the moving the positioner. Still, I think I could go a little faster. That was better, but I think I could still go just a little faster there.
There's the first one.
Didn't look too bad. Started out pretty decent, and then the heat started soaking in a little bit more because of the travel speed. So the other one, you can see it much more consistent. Much more consistent. So still has some work to do. Still has some, definitely a lot of practice yet, but that's better than the last time I tried it. So now I'm going to go ahead and do the same thing with the positioner, using it for the axle. All right, so I've got the axle bolt and adapter tack welded into position. I've got my aircraft positioner tipped at 90 degrees. I have my torch ready, so I am going to go ahead and try this one. All right, that's actually not half bad. Let's see if that shows up there. So that's actually not too awfully bad. Got a little wiggly, but let's that's for the most part, that's pretty decent.
go ahead and that one I bumped my current on the welder down just a little bit. Almost a little too far in that first little bit, but yeah, almost a little bit too much, but then it picked up. So, all right, so there's an axle, lightweight, ready to weld into the hoop. All right, so I've got the I got the axle centered on the hoop there, so we're good to go there. I'm just going to go ahead and put a couple little tacks. Go inside corner, inside corner. Okay, hopefully that shows up good. So there's the bottom hoop, ready to set the tank in place and weld the top hoop on. All right, so there's my test fit. Got everything tacked in place. Level that way. Level that way. So I think I'll pull the tank off. Have to go right-handed here, so bear with me on this one. Okay. Okay, that's pretty much welded. Bingo. Now I just need to put the base on, the handle on it, and a couple of attachment straps, or a couple attachments for the strap, and this thing is ready to paint